Welcome back, guys. Let's look at Codeforces Round 856. Problem B, not dividing. So we are basically given an array and we can perform an operation. The operation is as simple as adding 1 to any element of the array. Now there's a limit on the number of operations we can make. That is, we can make at most 2n operations. But then we do not need to minimize the number of operations. Any number of operations under 2n is fine. What do we have to do with the array? We'll have to make the array such that each element is not divisible by its previous element. That is, a of I plus 1 is not divisible by a of I. So let's look at an example. So for the array 2, 4, 3 and 6, as you can see, 4 is divisible by the previous element 2 and 6 is divisible by the previous element 3. So what they have done is they've added 1 to the element 2 times, so it becomes 4. Added 1 to the element 4 once and added 3 over here and added 1 over here. So the array is 4, 5, 6, 7. So now the number 5 is not divisible by 4. The number 6 is not divisible by 5. The number 7 is not divisible by 6. So we need to perform a sequence of operations on it such that the required properties are satisfied basically. Now let's look at how I solved it. So here's the given example. What they did was +1 and +1, +1 here, +1, +1 and +1 here, and +1 here. So it becomes 4, 5, 6 and 7. So this is perfect. But then how many operations did we do? 2 and here 3, 4, 5, 6, 7. 7 operations and 2n is equal to 8. So that's fine. So if you notice carefully, this is a really nice technique. If you can make the elements in ascending order like 4, 5, 6, 7, each element will never be divisible by the previous element. But then we can't use this logic because the number of operations might exceed the limit of 2n. Here we are lucky, but if there are some other numbers like 8 and then 16, we can't use this logic to add another 7 to it to make it 15, so that it's like an ascending order of 15 and then 16, right? We cannot do this. So what is the way to go forward? So one thing to be noticed from here is that in 4, 5, 6 and 7, it follows a even, odd format. So a even number can never be a factor of an odd number, right? So we can exploit this property. Suppose there's a number given like 5 and there's a number 2. So 2 can never be a factor of 5. So it's not a worry. But if there is 2 and suppose 6, then there's a problem. So what do? We can either increase this 2 to 3 or we can increase this 6 to 7, any of these, so that it becomes either 2, 7 or 3, 6. But if you see, in the case of this operation, that increasing the left hand side number, 3 is again divisible by 6. So it's always better to increase the right hand side number. Why? Like suppose there's an example of 2 and say 12. If you increase it once, it becomes 3. If you increase it twice, it becomes 4. And these numbers are continuously dividing the next number. So this issue can arise if you try to increase the left hand number. But if you increase the right hand side number, then this issue is taken care of. So we have understood that we have to first is increase the right hand side. But then when do we do it? If you look at the example here, 4 and 3, 4 does not divide 3, so you don't have to do anything. So what are the conditions? First we have to check that the next number is increasing, decreasing or stagnant. So if your first number is a, the next number can be increasing, stagnant or decreasing. Your next number B. So let's look at this decreasing case. If A is greater than B, that is, if the sequence is decreasing, then no worries, because the number will never divide the second number. Second case is that if the numbers are same, so let's say there's a 3 followed by a 3, then we definitely need to change it, and as discussed before, it's just better to increase the second number, so this becomes a 4. So if it is the same, then we'll increase the next number, which is basically saying ARR of I plus 1 plus plus, right? And then there's the third and most interesting case, which is increasing. In increasing, what we can do is, there's one property about odd and even, which we just discussed. If the left hand side number is even, then even if the right hand side number increases and it's an odd, then we don't need to do anything, because it will never divide. But if there's a even which increases to become another even number, then all we can do is just add plus 1 to this. And as we saw before in the example of 4, 5, 6 and 7, two consecutive numbers will never be divisible by each other in except one case, which is 1 and 2. In this case, the number 1 is a factor of 2, but then this is a special case. Why do I say this is a special case? Because if there's a number 1 followed by any number, let's say k, this will always be a factor of k, whatever change you do to k. So we can't allow any 1s to be in the sequence. So whenever there's a 1, you can perform an operation of increasing by 1 and change it to 2 in the array. Just while taking the input only you can do this, because 1 in the array is never acceptable, because it will divide whatever number is next, right? Anyways, coming back, in the case of increasing, if there's a even number, then if it is increasing and becoming an odd, we don't do anything. And if it is becoming an even, then we perform an operation, which is basically the same operation as this one, increasing the next element by 1. This leaves us with one last case. Which case is this? Last case is that it is increasing, but it's an odd number. Now, if the odd number increases to become an even number, we cannot say for sure that this even number is not divisible by this odd number. It might be. For example, if there's a 3 which increases to become a 6, then it is still divisible. So here the property of odd and even does not have any role. The odd might increase to an odd and still be divisible, like 3 and 9. So we just check that if the second number is divisible by the first number, then we increase the second number by 1. So in this case, 6 would become 7, hence not divisible. 9 would become 10, hence not divisible. So in increasing, we have two cases. The first number is even, in which case you can do this, and B, the first number is odd, in which case you can do this. So like, let's look at the code. So I've taken the input n and the elements of the array, and if any element is 1, we just increase it to 2. That's it. Now we run through the loop and we check if it is increasing, decreasing, or it's the same. For that, we just take the difference of the two elements, and I made a sine function. What the sine function does is basically, if the difference is 0, then it returns 0. If the difference is positive, it returns 1, and if the difference is negative, it returns -1. So in the case where both are same, we increase the next element by 1. If the number is decreasing, then we don't do anything. And if the number is increasing, if it is even, we check if that the next number is also even, we increase it. And if it is odd, we just check that if the next number is divisible by this number, then we increase the next number. That's it. Then we print the final answer. One doubt that may arise is, how is this following the constraints of 2n? So if you see, in the worst case, if all the elements are 1, we might have to increase all the elements to 2, right? So there are n operations here, and even in the second loop, whatever be the case, like is it decreasing, increasing, or remains same, we are doing at max one operation per element. So here at max one operation per element, and here at max one operation per element. So that's max of 2n. So yeah, that's it. I think this is exactly what I wrote. Yes, and this solution got accepted. Thank you guys for watching.